All right, so the factor theorem. With the factor theorem, that's sort of what we were talking about over here. Okay, so the factor theorem says if I have a polynomial, or given a polynomial, we should say, x minus a is a factor if and only if f of a equals 0. All right? And we can even extend it, okay? If we take our given a polynomial, so given a polynomial, the remainder after division by x minus a gives f of a. This is actually what's called the remainder theorem. It's just a generalization. Okay, so let's go ahead and use this. So a problem that we might have, or that we will have, something like it, is find k so that x minus 5 is a factor of f of x equals x cubed minus kx squared plus kx plus 55. So we're going to set up the synthetic division for this, okay? So we're testing, or actually we're going to make 5 a root, okay? Remember, it's if x minus 5 is a factor, then 5 is a root. So we're going to put 5 in the corner. We're going to have 1, negative k, that's the coefficient of x squared, k, that's the coefficient of x, and 55 along the top. All right. 1 comes down, 5 comes up. 5 minus k comes down. Now it's going to be 25 minus 5k. All right. Bringing this down, we get, is going to be 25 minus 6k. No, 25 minus 4k. Sorry about that. All right, just k minus 5k is minus 4k. I've done this problem so many times that I knew something was wrong. 5 times 25 is 125 minus 20k. All right. 55 and 125 minus 20k, so that's going to give us 180 minus 20k. Now, we're asking that this is a factor, right? So what do we need to have? Factor means we have a remainder of 0. Okay, so making the remainder equal 0, 180 minus 20k equals 0, or 180 equals 20k, k equals 9. All right, so 9 is the value that we need in order for k, in order for x minus 5 to be a factor of this term. All right. Okay. Let's go ahead and start with the rational zeros theorem. So actually there's two versions. I'm going to start with the light version of the rational zeros theorem first. So I have space. Yeah. These next problems get a little long. This is the light version. All right. So I just call it that. It's a little easier to see at first, and then we'll go to the full version. Okay. If we're given f of x equals x to the n plus a n minus 1, x to the n minus 1, all the way down to a1x plus a0, okay, then all possible rational zeros are factors of a sub 0. Okay, so now the key word in this question is possible. Okay, so when you see the word possible, what you're going to want to do is what we're going to do in the beginning of this next couple problems. Okay, so let's do just a quick example before we do a problem. Okay, so let's take our x squared plus 5x plus 6. Okay, now we know how to factor that. That's x plus 3, x plus 2. Now, if I was just asking for find all possible rational zeros, I'm assuming when I say that we haven't factored it. Okay, we don't have all the factors. We have here, but we don't have it. So we're just going to do it using the theorem. Okay, using the theorem. It's going to be the factors of 6. Okay, the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And so you can see that our 2 and 3 show up in that list. All right. All right, let's call it a video, and I'll see you guys in the next one.